Good day, everyone from Canada. In this presentation, I'm here to help you guys out with the unit circle. All right. So, to master the unit circle, you gotta know the equation of the unit circle. Know for x comma y, cosine is x and sine is y. Know the coordinate plane. Convert degrees to radians and vice versa. Know those triangles, 30, 60, 45, 45. And for sure, trig ratios and the Pythagorean. Those are things that you must know. You must know those things. All right. Reminders. Y'all, don't act brand new when you come back. Don't, because I can't keep going back and forth and on with the unit circle. If you don't got it at this point, after this video is Thanksgiving break, that's it. I can't go no further than that. Don't be brand new when you're doing these problems. Watch this video. We got a lot to do when we get back, so just know that. All right. I almost forgot to say this. Makeup work. That Thanksgiving package is gonna serve as makeup work. See to it that you are handling your business. Do not think, oh, I'm gonna pass this class if you know for a fact you didn't truly do the work or know the material. If you don't know those things, you're gonna fail. All right. Moving on. All right, so yeah, this is the unit circle. I know you guys been using it to get through the Kahoots. And that's cool and all, but the issue is you guys gotta understand the unit circle. If you don't understand it, it's literally no point of this. So I want you guys to work. So in this video, I'll be asking for the outside part of the unit circle. So when I'm asking for those values, I'm asking you for what's in the outside. The questions that I would be asking, like, what is cosine of 30 degrees? I'm looking for what's in the inside. Or give me cosine of pi over 4. So all this right here, I'm trying to highlight something good. Why is it not doing it right? Hang on, I'm sorry, y'all. Technical difficulties. Okay, I think I got it. So there we go. Everything in the inside is going to be questions. Everything in the yellow is going to be answers, all right? The radians and the degrees will be the questions that I will be asked, that I will use to ask. All right? So I decided to do you a little table or whatnot. A little table to kind of help you understand these things. So what is sine again for the trig ratios? Sine is I hear you. The trig ratio for sine is going to be opposite over the hypotenuse. Cosine is going to be what? Adjacent over the hypotenuse. And then tangent is going to be opposite over the adjacent. Now these three things, I mentioned this to you guys in class before, but I know you guys forgot, so I'm going to go over those again. So I'm going to draw arrows to illustrate this. So cosecant is the inverse of sine. So that is hypotenuse over opposite. That's something, again, you must know. Again, you can't keep, oh, I forgot this, you're going to fail. Secant is the opposite of cosine. And so that's going to be hypotenuse over adjacent. And cotangent, let me use a different color. How about that? I'm going to use black on this one. Let me erase all that because that's a little hard to see over there. So cotangent is going to be adjacent over opposite, and that's going to be the inverse of tangent. There we go. That is what I'm asking you for. These are these things about. All right? So now, let's go through all this. All right? And again, for the degrees, remember we got these degrees from the triangles we did, the 30, 60, 45, 45. So when you're doing these trig stuff, it does get, you could get confused easily from this because sometimes I get confused too. And that's the reason why we spot a great length of this unit circle, because I do understand how I get confused. So here's one thing I want to address with you guys. I know for a fact you guys are so used to the long leg, me too, being here, and the short being right here. And the hypotenuse is going to be right here. That's true, but here's what's happening. The long and the short leg is going to switch. And here's why. At the unit circle, for the 30 degrees, let me draw this right. No, I'm going to draw this a little bigger because I want you guys to see everything that is coming, where I'm coming from. So here's what 30 degrees look like. So for the 30, the long leg is going to be here, and the short leg is going to be here, and the hypotenuse is going to be there. Again, I do understand why you got this backwards, because even I get this backwards. All right? But that's only for the 30. So let's go and use what we know about the 30. So for 30 and the 60 degree angles, if I'm given the hypotenuse of 1, and remember the hypotenuse is the radius, and remember x squared plus y squared equals r squared, and r squared equals 1. And that's the radius of the circle, which is known as the hypotenuse. Make sure you know that r is the radius of the circle. The radius of the circle of the unit circle is the hypotenuse for all of these triangles. So let's do it. So I just told you that the hypotenuse of the 30 is going to be 1, right? So the short leg, to get to the short leg is going to be 1/2. Remember, the short leg is half the hypotenuse. The short leg is half of the hypotenuse. The short leg is half of the hypotenuse. The short leg is what? Half of the hypotenuse. All right? So let's do the long leg. The long leg, we know from a 30 degree is the square root of 3. But remember, the long leg of a 30-60 triangle is short times square root of 3. The long leg is short times the square root of 3. The short leg is, the long leg is short times the square root of 3. The long leg is short times the square root of 3. The long leg is short times square root of 3. The long leg is short times square root of 3. The long leg is what? Short times the square root of 3. Okay. So it's going to be 1/2 times the square root of 3, which is square root of 3 over 2. All right. There, we got our stuff together. All right. So that's what you start out with. So with that being said, let's build this up. So let's go find sine. We know sine is the opposite, which is 1/2 in this case, of the hypotenuse. 1/2 divided by 1 is what? 1/2. Remember, 1/2 divided by itself, 1 is going to be itself. So boom. That's sine of 30 degrees right there. So what if I was to say, give me cosine pi over 6? Well, suppose that you try to figure out that degree. To do that, remember you got to times it by 180. So that's going to be over pi. So that's 180 divided by 6, which is 30 degrees. So that's how we know cosine is 30 degrees. So now let's do it. And because cosines are 30 degrees, because that's how we found out, there we go. So now, let's do it. Cosine is going to be square root 3 over 2 divided by 1, which is square root 3 over 2. And guess what? We just figured this out. We just did that one right there. See how we did that one? I'm going to deal with the 0 degrees right next. So let's find tangent of 30. Now I'm asking you to find tangent of 30. Again, pi over 6 is 30 degrees. Now let's do tangent. So we know from what we found out, sine before we do that, we know that tangent is consisted of sine over cosine. Where did this come from? Let's go back and do what we did in class earlier with tangent. So sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Right? We know those trig ratios, so let me erase this. All right, so let's go divide. So if I'm dividing those two rational numbers, we keep opposite over the hypotenuse, multiply, and then we're going to flip. So when we flip, it's going to be hypotenuse over adjacent. So what cancels? So both the hypotenuse cancel, And then we're left with opposite, which was the sine. Cosine is adjacent. And therefore, tangent is sine over cosine. All right? And that's how we create tangent. Tangent is created from the combination of sine and cosine. Tangent is created from sine and cosine. Tangent is created from sine and cosine. Tangent is created from what? Sine over cosine. So now with that being said, we know that sine is 1/2, right? Because sine over cosine, so 1/2 divided by the square root 3 over 2. So let's rewrite this. So 1/2, you keep, you change, and you flip. When I cancel the twos, I'm left with 1 over square root 3. But let me ask you a question. Can I leave that as that? No, I got to rationalize the denominator. So, square root 3 times the square root of 3. Square root of 3 is 3 times 3 is 9. Square root 9. And that's just square root 3. And my final answer is going to be, I'm going to put it underneath right here, square root 3, because we know that the square root of 9 is 3, so square root 3 over 3. So guess what? We just figured out our answer for sine, cosine, tangent. So, we did that one. So what if I was to ask you to find the inverse of sine, which is cosecant? So we know it's 2 just looking at that, but why is it 2? Why is it 2? Because remember, sine is opposite over the hypotenuse, which we found out to be 1/2. But if we flip it over, because remember, cosecant is going to be hypotenuse over opposite. See, because we have to flip the trig ratios over, now we got to flip over that 1/2. So when we flip it, it becomes 2. Bam. So that's cosecant. All right. Yeah, that's cosecant. So let's find secant. So we know that secant is the inverse of cosine, which is adjacent over hypotenuse. And of course, secant, you just got to flip it over to be hypotenuse over adjacent. So when we do that, we know that cosine is square root 3 over 2. Flip it over to be 2 square root 3, which we know we can't have that. So guess what? When you see a radical in the denominator, you gotta do something about it. So you gotta multiply the whole rational number by square root 3. So 2 times square root 3 is 2 square root 3 over 3 times square root 3 is square root 9, which we know for a fact is going to become square root 3. Just like that. And that's where that comes from. I'm not going to cotangent because if you just understood how we just did secant and cosecant, you could do cotangent yourself. So I won't explain that no further. All right. Let's go ahead and look at the 0 degrees. Because I know that's going to be one that I know I didn't talk too much about that you will struggle with. All right. So, 0 degrees. When you do your unit circle, remember the radius is 1. So what that means that the outer part of the circle are all going to touch 1 somewhere on the x and the y. So that means that when you start in the first quadrant, 0 or 360, your x-intercept is going to be 1, 0. And we know for a fact that 1 represents cosine, 0 represents sine. So on that, it touched there. So what about when I get to the y-axis at the top? So that means that that y at the top is going to be 1, but x is going to be 0. All right? And that's at 90 degrees. We know that. So when the x-intercept had the distance of 1 here, what's it going to be in quadrant 2? -1, 0. How many degrees is that? 180. Okay? And then if I'm touching 1 at the bottom of the of the y-axis, it's going to be what? 0, -1. How many degrees is that? 270. So now with that being said, let's go ahead and do it. So if I was to say, give me sine of 2 pi, there's also saying 360 degrees. How did you get that? How did you get that? All right. So let's do it. Remember, if I got 360, if I'm trying to convert it to radians, guess what? I got to divide this by 180. And don't forget I have pi at the top. So 360 divided by 180 is what? Use your calculator to find out. 2 pi. So now let's go answer the question. If sine is 360, 2 pi, which is 360, what's the value of that? The value of that is going to be 0. Zero. If I ask you for cosine of 0, it's going to be 1. But if I ask you for tangent of 0, we know 0 divided by 1 is 0. So what does it mean for something to be undefined? So let's do cosecant then. So we know cosecant is the thing for sine. So in this case, the reason why it is undefined because cosecant, these three trig ratios right here, have no way of rewriting that. So we know that sine opposite over the hypotenuse, and we flip the out as cosecant, which is the hypotenuse over the opposite. Cosecant have no way of another form of 1 over sine. So with that being said, y'all, we know for a fact that sine was 0, right? So 1 over 0, guess what? That's undefined. So that's where that comes from. All right, I think you guys got the hang of this. And this is all in quadrant 1. So let me ask you a question. What if I was to ask you for the tangent of pi over 2? So if it's pi over 2, if you don't know by now that that's 180, that's saying tan of 180. Why don't you convert this radians to degrees? Convert this radians to degrees. And that's for you. In case you forgot, go back to the previous video and find out. So yeah, pi over 2, just looking at my table and for knowing that pi over 2 is tangent of 90 degrees. I'm going to erase this right here. So we know that it's tangent of 90. So when it's tangent of 90, I know it's going to be undefined. Why is that? Because tangent is sine over cosine. So remember, tangent is sine over cosine. So 1 divided by 0 is undefined. All right. And again, if you don't understand that part, just go back to the part where I was talking about how tangent was created. Again, tangent is sine over cosine, so 1 divided by 0 is undefined, and that's where we get this guy from. All right, moving on. All right, y'all. So by now you should be able to pick up a pattern. So cosine goes 3, 2, 1, 30, 45, 60. So that's how it goes for cosine. 3, 2, 1. And sine, is going to go 1, 2, and 3. So 1, 2, 3 for sine, and cosine is going to go 3, 2, 1. I do get these backwards from time to time, and I do understand you guys get these backwards too. But just remember, cosine 3, 2, 1, sine goes 1, 2, 3. All right, so let's do it. Now, we're no longer in quadrant 1 because the last thing we did was in quadrant 1. And we know cosine sine, cosine is x, y is sine. So in quadrant 2, what's going to be negative? x is going to be negative, and we know x is cosine and y is sine. So you got to know your coordinate plane. So quadrant 3 is going to be negative x, negative y, and then 4 is going to be x, negative y, and then quadrant 1 is going to be x, y. So you got to know all of this. If you know this, you're going to be all right. So let me ask you a question on this. Again, I have the table for you, and the table is for you to, you can memorize, cool, but you got to try to understand it too. So what if I was to say sine 5 pi over 6? All right, so suppose I don't have a 5. Just treat it like it's pi over 6. We know pi over 6 is 30 degrees. We know that. And we know that sine of 30 degrees is going to be 1/2. So the question is, from there, you got to figure out, okay, what quadrant will I be in? To know your quadrant, do the following. Remember I told you about converting radians and stuff into degrees? We just figure out. So take 5 pi over 6 times it by 180. And of course put it over pi. So let's multiply. The pi doesn't matter because the pi is going to cancel out, so don't you be worried about the pi. 5 times 180 is 900, right? 900 divided by 6 is 150. Okay, so almost done. Almost done. So ask yourself, 150 degrees, which quadrant is that in? That's in quadrant 2. Now because we know it's sine, we're going to be a positive 1/2 or a negative 1/2? Positive, because sine being the y value is positive. So that's why we get 1/2. And that's all you got to do for those things. Just that. So it only gets harder if I'm asking you for radians. If I'm asking you in terms of radians. We're almost done. All right. So what if I was to ask you for tangent of 150? You know for a fact, tangent of 150, again, we know that 150, if I was to convert this to radians, is 5 pi over 6. Anything with pi over 6 is 30 degrees, which tangent is sine over cosine. So that means I have to both know sine and cosine. So cosine I know for 30 degrees is going to be square root 3 over 2, and tangent is going to be 1/2. I mean, sine is going to be 1/2. All right? So we got that situated. Now we got to finish it up. So what's tangent? Tangent is sine over cosine, so 1/2. And I'm working right here. So keep, change, reciprocate. Keep 1/2. Change the division and multiplication. Reciprocate square root 3 over 2, which is going to be 2 over square root of 3, which we know we cannot have that. So that's going to be 1 square root of 3. All right. So let's flip this around. Well, to do that, we got to multiply by square root 3, square root 3. So that's going to be square root 3 over square root 9. We know square root 9 is just 3 over square root 3. I'm missing one little thing, and that's going to be the negative sign, because 150 is in quadrant 2, and we know that cosine is negative there. And we know that the trig ratio for tangent is sine over cosine. And because cosine negative, that's going to make the whole thing negative. And that's all you have to do. That's it. And that's how you do that unit circle. And that's all the stuff in quadrant 2. All right, y'all, this is all the information for quadrant 3. If you understood what I did in quadrants 1 and quadrant 2, you should be good. All right? And remember, for the trig inverses, like cosine, say you had cosine negative 3 over 2. Suppose you had that. Well, secant, remember, is going to be 2 over square root of 3, which you know we can't have that. So multiply by square root of 3. And we know that this is going to be 3 right here, because square root of 3 times 3 is 9. And square root of 3 is, the square root of 9 is 3. And then it's going to be 2 square root of 3. But suppose if I had cotangent of 270. So remember that now you know that tangent, because you got to know what is tangent. In this case, remember, it's going to be sine over cosine. And we know that sine of 270 is going to be 0 all right? What am I doing? Hey, who's bothering me? I'm sorry. Okay, get back to it. All right, so we know that tangent is sine over cosine. Sine of 270 is actually -1. And cosine is going to be 0. If I flip it over, cotangent is going to be 0 over -1, which we know is going to be just 0. And that's how you do that. See how I went to the trig ratios and stuff like that? And do that. Oh, I see. You guys got confused what I did earlier. Because I told you guys about like cosecant and whatnot. So yeah, cosecant has that trig ratio of 1 over sine. To be honest with you, you don't have to think of it like that. Just if you know that cosecant, you just flip over from hypotenuse over opposite. Well, the sine is going to be opposite over hypotenuse. The sine is going to be opposite over the hypotenuse. So look, so cosecant and secant are what you're going to worry about. Cotangent was easy. So okay, we could do cosecant. So let's do cosecant of 270. So cosecant, the trig inverse is sine. But to do that, remember it's going to be 1 over sine, which we know is going to be 1 divided by -1, which is going to be -1. Let's do secant of 270. So secant is 1 over cosine. So that's going to be 1 over 0, which we know is undefined. They can never happen. And that's pretty much just that. And again, going back to cotangent of 270. Cotangent is a little bit different, because to do cotangent, you definitely have to understand what tangent is, in which we know tangent is sine over cosine. So sine is -1, and then cosine is 0. Well, guess what? Cotangent, you got to flip it over, which is going to be 0 divided by -1, which we know is 0. That's my final answer. And that's it. And that's quadrant 4. And we already did 360 and 0 is going to have the same values, which is going to be 1, 0. Just remember that. And remember, this is sine, cosine, tangent, cosecant, which is the inverse of sine, secant, cotangent, which are inverses. So remember, if I say sine, if I say the inverse, I'm saying cosecant. If I'm saying cosine, I'm saying the inverse of secant. And then if I'm saying tangent, I'm saying sine over cosine. But if I'm saying cotangent, rather, I want you to do cosine over sine. It does have 1 over tangent too, but that's going to confuse you. So just remember what cotangent is. And that's it, y'all. Good luck. Oh, one more thing before I let you go. The Pythagorean. So guys, remember a squared plus b squared equals c squared, right? But when it comes to your unit circle, it's going to be x squared plus y squared equals 1. Remember that. That's going to play into what we're doing, because that's the equation of the unit circle. So you guys know how to do the Pythagorean theorem pretty good. So, and we did the trig ratios. So that's just pretty much just it. All right, y'all.